Right, hello, welcome to a new video. It's been a little while. I've been training to become a maths teacher, which has been really fun. However, this has meant that I've had less time in the evenings, I've come back from work and I've been quite tired. I've not really been motivated to make many of these videos, which is fine. I've kind of put this channel on the back burner, but I'm looking to revive it a bit. Kind of come back to it here and there when I feel like it. So here's a problem that I found whilst in my school time, which introduced me to by a fellow teacher. I thought it was quite a fun problem, so I thought I'd make a video out of it. And here is the problem. It says there are R red counters and G green counters in a bag. The probability of picking a green counter is 3/7. 2 red counters and 3 green counters are added to the bag. The new probability of picking a green counter is 6/13. Find R and G, so the original number of red counters in the bag and the original number of green counters. So, let's pick up the pen, let's get down to business. So, the probability of picking a green counter, and this is before we add any to the bag, so let's just write before, above. Probability of picking a green counter is 3/7. How do we express this using our R's and our G's? And this was the first big step which you have to kind of acknowledge is how we do this. We not only express this in terms of numerical probability, we express this in terms of algebraic probability. And how do we show the probability of picking a certain coloured counter from a bag of counters? We say, right, how many of the counter is there in the bag we're looking for? We divide that by the total number of counters. We say, right, how many green counters are there in the bag? There's G green counters. So we say, right, the probability is G over the total number of counters. We know that there's only red and green counters, and we know that there's R red and G green. So we say it's R plus G, which is the total number. So the total is the bottom, and the intended outcome, the number of counters we're looking for. You get the idea. I don't really have the space to write all that, but in fact, let's rub all that out. Let's get rid of all that. Yeah, but you get the point. Well, I don't know if you get the point. Let's hope you get the point. So at this point, well, I'm saying the word point a lot. We have these two things here. We can equate them. We can express R in terms of G by solving. So what we can do, we can cross multiply. We can times both sides by 7. We can times both sides by R plus G. This gives us 3R plus 3G equals 7G. We can just take 3G off both sides. We get 3R equals 4G. We have an after as well. This is the before. Then we know that 2 red counters and 3 green counters are added. So the new probability of G is 6/13. And algebraically we express this as, okay, so how many counters are there in the bag? Well, there's the original number of counters, which is R plus G, plus 2 new red and 3 new G. Well, we don't know what R is, we don't know what G is, so we just say that there are 5 new counters added altogether. So R plus G plus 5. And on the top we're looking for green counters, it's G plus how many green counters were added? 3 green counters. So we say G plus 3, the original number of green counters plus 3 new green counters. And we do the same as we did before. We cross multiply and we solve so we can express R in terms of G or G in terms of R. So we times both sides by 13, we times both sides by R plus G plus 5. We get 6 lots of R plus G plus 5 equals 13 G plus 3. We expand. 6R plus 6G plus 30 equals 13G plus 39, and then we just tidy it up. We take we take the 6g off both sides, we take the 30 off both sides, so we're left with 6r equals 7g plus 9. This equation here, we'll call it number 1. We're going to multiply both sides by 2. So whatever we have on the left hand side, these two things are equal. We're going to double both sides so they're still both equal. And what we get is 6r equals 8g. 6r, 6r. These two things are the same. And I've done something to end the slideshow again. I'm not sure what that was. That's quite annoying. Yeah, sorry, so now what we do, we have 8g equals 6r, we have 7g plus 9 is 6r. So what we're going to do, we're going to replace 6r with 8g. We're going to say that 8g equals 7g plus 9. And this gives us g equals 9. We take 7g off both sides, we get g equals 9. So we know the original number of green counters now. We know that there were 9 green counters originally in the bag, and then we just have to say, right, okay, this equation here is the one with the smallest number of things, with the smallest coefficients. This is going to be easier for us to work through. Let's go through it. So let's say 4 times g, 4 times 9 is 36, 3r equals 36. We divide both sides by 3, r equals 12. So we know that there are 12 red counters originally in the bag. I would love to know what I'm doing to cause that. It's really getting on my nerves. But you can see everything there. You can see the whole shebang there. That's the end of the video. That's everything that I needed to do today. That's everything I've solved the problem. It says find r and g. R is 12, g is 9. Thank you for watching. I hope you enjoyed it. I'm gonna make another video on a different problem, which I think should be quite a fun one. Thank you for watching. Goodbye.